sending you this letter. As we discussed, at this point I must stay anonymous. The fluid control industry is a small sending you this letter. As we discussed, at this point I must stay anonymous. The fluid control industry is a small village. Let us just attention to certain aspects of seals, valves, and actuators that must be part of any artificial environment to maintain life and functionality. I have no special knowledge of the ISS, but there are principles of fluid and motion control that cannot be ignored. We assume that the ISS has supply systems for water, fuel, air, etc. These systems would all require valves, pumps, and seals at a bare minimum. Without systems to deliver, send, expel, vent, filter, and store these fluids and gases, life on board would be impossible. Tubing, pumps, tanks, and valves would need to be present across all of the living areas to assure, at the least, fresh air. Seals, such as O-rings, would be required throughout the ISS to hold in gases and fluids. Valves would be required to meter these gases and fluids and to maintain proper pressures. Actuators would be required to move devices such as the Canadian arm, hatch openings, etc. Anything that is not moved manually requires an actuator. Let's look at some of the questions that pose a problem. Okay, so that was the end of his little preface. And then he goes into the first thing he wants to address is seals. And here we go. For aerospace applications, the most commonly used seals and O-ring materials, and we're going to get into a couple technical things here, are GLT-type fluorocarbon. ISS is being exposed to temperatures beyond this range. There are special Teflon-based seals available that can extend a little past this range, but they are not made with flexible or compressible materials. Therefore, the mating components would have to be manufactured within a millionth of an inch tolerance to prevent a seal from moving and thus leaking. Not convenient for a hatch or a fuel valve that is in constant use. Perhaps the seals are shielded from the temperature changes. Perhaps. But the outside of the ISS does not seem to show the insulation units required to accomplish this. Another problem with seals is that they wear out. Seals would have to be replaced frequently. Preventative maintenance of seals and sealing services would keep a maintenance team busy 24 hours a day. Seal replacement would require sealing off areas, cleaning and sealing surfaces, since in many cases a human hair can cause a seal to leak, lubrication, polishing sealing surfaces, or replacement of modules, etc. I do not think any of these things have been observed on the ISS. Seals also require back pressure to seal. I have no idea how a seal would function against a vacuum. We have no calculation for it. Any seal I have ever seen would simply be sucked out into space. How fuel, air, water, etc. are all contained and moved in the ISS space station reported an ammonia leak near that same location